First law of thermodynamics. So ఏంటి the first law of the thermodynamics అంటే total heat supplied ఏ విధంగా యూజ్ అవుతుందన్నా some part of the total heat supplied will be used to raise the internal energy to do the work. That is some external work అనేది జరగాలి అని. ఓకేనా? In the sense, if dq is positive, ఒకవేళ dq గనక పాజిటివ్ అయితే ఓకేనా అంటే దాని మీనింగ్ ఏంటి హీట్ ఈస్ ఎస్ నానా and dq is equal to du plus dw. So in this one, first case I'll see that all the work done is positive means heat is supplied. Heat is indake raskunnana supply by the system. Okay na? So this is the basic condition andi. So dq is equal to this is your du plus dw situation. So దీన్ని మనం ఫస్ట్ లా ఆఫ్ థర్మోడైనమిక్స్ అంటాం ఇందులో పాజిటివ్స్ ఉంటాయి some negatives will also be there. So depend upon the situation we'll be deciding whether the positive or negative. Heat is flowing into the system ante internal energy increases. Heat is coming out of the system ante internal energy is going to be decreasing. Okay na? So these are certain things please which are going to be defining us as the basic thing. So coming to us. So this is our first law of thermodynamics, that is the total heat supplied will be utilized to raise the internal energy as well as to do the external work. Now I am writing the process. What do you mean by process? It is a method by which you can change physical quantity. The method by which pressure, volume and temperature okay na to be changed. So because this is the one which has been changing like this. So in this one we can go for the first process is isothermal process. So isothermal process and the process in which temperature remains constant. T is equal to constant. So temperature constant kabatti PV is equal to, I'm writing it as a constant. Okay. So now in this case, what are the other parameters that we can write for an isothermal process? So work done under the isothermal process is going to be work is equal to, on solving you will be getting nRT into log of log 2 minus or log V2 volume in terms of this could be log V2 by V1. So this is your correspondingly the work done, or if I want to change it to the log base heat 2.303 into log 2 or else convert chesam kabatti log of this is V2 by V1. Okay na? So this will become as a log base 10 kada. Now if pressure that is P1 V1 is equal to P2 V2 kuda equal avutundi because temperature is constant. In the place of V2 by V1 I can also V2 by V1 that is P1 by P2 kavali. Okay na? So that's going to be the difficult task please. So from this one you can write it as an P1 by P2 or change in pressure or P is equal to minus of delta P by delta. This is the condition that is dV by V. So దీని ఏమన్నా bulk modulus under the isothermal process కాబట్టి pressure and bulk modulus will be same. Work done formula రాసుకున్నాం కదా నాన్న. So these are the different things regarding this process. Next we will go for adiabatic process. So what is this adiabatic process? dq is equal to 0. Q is, okay, now, so what do you mean by Q is? This is going to be the heat supplied or heat thing. And the exchange of the heat should not be surroundings from the body to the surroundings or surroundings ki body. అంటే హీట్ అనేది బాడీ నుంచి సరౌండింగ్స్ నుంచి బాడీకి ఎక్స్చేంజ్ అయ్యే ఫిజికల్ క్వాంటిటీ అది. Okay, so now this is the condition. Work done in this case will be work done is equal to. So that is 2.3 into nRT into ln of, that is V2 by V1. Like this, you need to substitute 2.303 and you need to solve it. Right now, then slope ento sundra. Slope, that is curve dP by dV is equal to minus gamma P by V. Okay, so this is just slope conditions or whatever is going to be the thing. So the same work done can also be written as in 2.303 where. So sorry, in conversion in this one, nRT ln of, instead of V2 by V1, we can also replace with the P1 by P2. So in either forms, you can use this one. Now coming to the adiabatic process. So here, this is the slope. It does not obey that particular thing. So in this one, in the adiabatic process, what will happen? P V power gamma is equal to constant. We consider that this is consideration. Avuna? So P V power gamma is equal to constant. So since dq is equal to du plus dw. Okay, so total heat supplied is used as an internal energy and to the external work is rendu చేసేటట్టుగా ఉండాలి. ఓకేనా? నెక్స్ట్ ఇందులో రిలేషన్స్ ఎలా ఉంటాయి? P V to the power of gamma. Next one. What is the next stage? That is the relation between the volume and temperature. What is the relation between the volume and temperature? I have to remove the P. P can be eliminated from the ideal gas equation nRT by V. So ikkada denominator, so this is the case nowadays. So P V power gamma అనేది is going to remain as a constant in this particular adiabatic process. మరి temperature కిను P కి కావాలంటే T power gamma into P to the power of 1 minus gamma is equal to constant. Okay, అదే మూడోది third type is T into V to the power of minus 1 is equal to remains as constant. So these two are the very, very important tasks. Please be careful. Okay, so under the adiabatic process, the work done can be written as and it is equal to 2.30. So 2.3 into nRT. Okay, now so 2.303 into nRT, this is the formula. Or you can, if I want to write, you can also write it W is equal to nR by gamma minus 1 of, this will be the T1 minus T2. So this is the work done under the adiabatic process. So remaining whatever may be the cases, you can apply, that is for an isochoric. For the isochoric process ante enti? Okay, na, so in this case, volume remains constant. Okay, isobaric process ante? Isobaric means pressure remains constant. Pressure is constant. Right, Anna? So these are the different processes. That is called as a polytropic process. So polytropic process. So there are the different kinds, different situations, different situations. So simultaneously, work done can be written as, and this is nR by nR into T1 minus T2 by gamma is correct. This is your work done under the process. Depend upon situation, you can apply the different things. So these are the different processes are there where we'll be dealing with the things. And the shape of the graph between the slope, that is E and V. Okay, now, so they will be starting from a point. This represents your isobarica number one. Isobaric కదా ఇది isobaric కాకపోతే ఏమొస్తుంది అదే చెప్పండి. So this is your isobaric process, that is the pressure and volume. Pressure at any given volume, it will be the same. Next, this is your isochoric, whatever this one are being rectangular cases hyperbolous. So ఈ type లో వస్తాయి నన్ను. సో దాన్ని సాల్వ్ చేసుకుంటే మనకు వచ్చే ఇవన్నీ ఐసోకోరిక్ లోను ఐసోబారిక్ ప్రాసెస్. And correspondingly the work done is going to be here only. Right, sir? So in this case, the bulk modulus K is equal to, so we can have, that is an bulk modulus K, no? I want to establish a relationship between the pressure, which is equal to the gamma P negative. This comes under which process now? Adiabatic process, right, sir? So work done will be different and heat supplied will be different and heat utilized will be different. But sum of heat utilized and rejected, you can call it as a total heat or anything like that. Okay. So next case is in this one polytropic process also we have seen. So in the isochoric process, if I go for the deeply, in isochoric process or isothermal process, so in this one du will be 0, that is temperature remains constant. Temperature constant undi, du is equal to 0, which can be written as an, okay, how do you write this one? Du, that is dq is equal to the దీంతో ఈక్వల్ అవుతుంది ఇక్కడ. So it is working at the constant volume and good volume is not increasing. So change in internal energy is going to be delta U is equal to 0 for the generally. It is 0 ga maintain avutundante, in the sense temperature internal energy will not increase, it remains as a constant condition. Constant gaane untundi isothermal process lo. Okay na. So these are the different situations andi ikkada. So slopes ni batti veetini batti teeskuntu vellali. As in the earlier case I have drawn this graph is going to be isothermal aithe, this is going to be the isobaric, this is isothermal. Okay, and the third one is adiabatic. Okay, now this is the last in this case, that is iso. This one is going to be the isochoric. So the isochoric. So different processes are there for the different situations. So we can able to solve them. This is the this thing comfortable.